Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In last two sessions, we created this power supply. I will apply power. I will connect load. Now I am controlling voltage. And from here we will control current. And then we will connect this Deek-Robot BL-02 meter. Here are two different cables. One is 3-wire cable and second 2-wire cable. In this wire, red wire positive 7 volt to 12 volt to power on this device. Black is return path. White wire is used to measure voltage, where we will connect. It will sense the voltage from there, and maximum 100 volt can be applied to this multimeter. Meanwhile, these two wires are used to connect this current shunt here. The current will flow from this device. There is a special technique to connect this multimeter. Mohan Raja, welcome brother. Thank you for joining. There is a special technique to connect this multimeter when we are working with DC power supplies. Regulated power supplies, we are sensing current from this shunt resistor for our control circuit. But if you want to connect this one, we will discuss in detail what are the basics. How to connect this. If you will connect directly, what will effect on the circuit? First I will connect this meter to measure current. DC ampere. When we want to measure current, we will connect multimeter in series. Multimeter common wire will be connected at negative side output terminal, and this will be connected to the return path of the load. This time we are taking out 1.8 ampere, 1.7 ampere, and if I will check voltage, we are taking output from this power supply 3.37 volt, 1.7 ampere. If I increase voltage and we will increase current, we can see this time we are working in constant current. Now I am increasing current. Brightness of the lamp is now increasing. 2.7 ampere, 2.8 ampere, 2.9 ampere. That means it is controlling current. The lamp is now full bright, and we are taking output 3.24 ampere to 3.22 ampere. This is the current now. If I increase voltage, now voltage are increased 12 volt, 12 volt, 3.5 ampere. If I decrease voltage, voltage will decrease and current will decrease, because now we are working in constant voltage mode. Coarse voltage adjustment, fine voltage adjustment, and this is current adjustment. I love your videos. That is first time I see you. Sending love for the most welcome, brother. Thank you. Okay. This time we are working in constant voltage mode, and this is constant current mode. Now we want to measure voltage using this BL-02 voltage, ampere and wattmeter. It will calculate three things. First, we need to connect supply voltage, that are these two wires. Return path, positive voltage, that are 7 to 12 volts. And this is measuring point voltage, from where we will measure the voltage. Now I need to connect return path. I will take return voltage from the same, the output terminal. So this is our return path. that is output of this power supply. Still, this circuit needs many improvements. After completing this circuit, I will share its diagram. You can also watch the last two videos, 1336 and 1336A, so that you can check the result of this circuit. Practically, we are controlling current and we are controlling voltage. So you can make this circuit for your lab. It is using very simple IC, LM324. Now I will connect 12 volt positive that are here, that are from this point. These are 12 volt. We are injecting external 12 volt to power up this circuit, control circuit. In upcoming sessions, I will connect transformer so that we will use only one transformer to power on this circuit and provide voltage to this output transistor for regulation, and we will also use same voltage to control this IC. Now the multimeter is powered on. I will connect positive wire, this sense line, to the output terminal that is here. So it will show the output voltage. Yes, now I connected this meter. It is showing 5.2 volt. This external multimeter is showing 4.93. We need to calibrate it. Yes, now it is 4.9 volt. The same 4.9. Here is adjustment on this meter, and it is very cheap. You can find it online. 4.9 volt. This time it is not showing any current because we did not connect these two wires. Let's connect the current sense. Let me decrease the current. Now the current is being controlled. We can see 1.8, and the load is also being dim. It is becoming dim. This time I am using just only one transistor, 2SA1941. It is 10 ampere transistor. When we are designing DC regulated power supply, that time 1/3 value is excellent. That means we can use 3.3 ampere, 4 ampere. That's good. Naresh Kumar, we are making a regulated power supply. We are using A1941 transistor, LM324. I connected this assignment in first video number 1336, to control the voltage. And in next session, 1336A, I shared its procedure how to control the current. And this time we have current control and voltage control on this circuit. This time I am making it prototype to understand the function, how it works. And then I will build it on a Vero board, or we will prepare a PCB. Then I will assemble it in a box. So until now, we controlled the voltage. So this power supply is working now in constant voltage mode and constant current mode. And in this session, I am connecting this multimeter. This is Deek-Robot BL-02. When we are using one shunt resistor here, current sensor resistor here for controlling this voltage, now here is a special trick, special technique. Yes, it is variable. Variable voltage, we can vary from 0 volt to 28 volt. Let me disconnect load. I will disconnect load and then now we have 5.2 volt and this meter is showing 5 volt. Here is voltage control, coarse voltage, fine voltage control. We have capacitor bank and there is discharge resistor as a bleeder. Now the voltage will 0. Because load is not connected, so capacitor is charging slowly. Capacitor is discharging very slowly due to this low value resistor. Now I will increase voltage 1.6 volt, and if I want to increase millivolt, I will use this fine voltage control. Sorry, we can see it is increasing in millivolt. 1.741, 1.742. You can watch video number 1336 on my channel to make this voltage control. So it will increase voltage in 100 millivolt, 200 millivolt maximum. But from here, 13 volt, 16 volt, 24 volt, 25 volt. Maximum 27.8 volt, because I am just injecting voltage from this power supply, that is SMPS 28 volt power supply. If we have transformer, we can control any voltage level. We will inject through this transistor, it will control. Just we need to reconsider the resistance value in the feedback network. Yes, welcome, Abedin. Thanks for joining. And here we have current control. I have 27 volt output. Now I will connect load. First I will make 0 to the current. We can see this time the voltage reached to 0 because I decreased the current. Now I adjusted the current to 100 millivolts. So it is now constant current mode. Before this it was in constant voltage mode, but now constant current. Voltage are still 28 volt, but the current is 200 millivolt, 200 milliampere, sorry. It is constant current. If I will disconnect the load, the voltage are 27.8 volt. Now I disconnected load, voltage are 27.8 volt. But if I will connect load, it is now in constant current mode. In next session, I will connect current limit, voltage limit. We will make many improvements in this circuit to make it safe. We need to inject over voltage protection. Let's suppose I want to use this circuit for 12 volt due to any reason. If the voltage are 13 volt, that time this circuit must protect the load. So it will go in protection mode. Let's make connections for this current now. Now it is showing 8 volt and we have 8.68. Eight point 6 volt. Here we need to understand a very special thing. Yes, this video will available on my channel in the video section as well, because it is numbered as a 1336B. That is third part of our last these videos. 1336 and video number 1336A is also available. Now we need to understand a very special point here. This is our negative output terminal. Positive regulated voltage are out. We are taking output from this resistor, I sense resistor, this one, current sense resistor. Thank you, Isam 95, thank you. Now, this is return path which we connected to our control section. That is our reference point for this IC. That is this return path. It is very technical point. If you are connecting any multimeter, any ampere meter to measure current with combination to a current control circuit in any regulated power supply, let's discuss and then I will make connection. We are taking a signal out from this point. That is I sense, current sense. In our last calculation, we considered if 5 ampere current, I is equal to V is equal to I into R, we considered 5 ampere output current from this circuit. And resistor value is 0.115 watt. I discussed 5 volt multiply with resistor value at full rated current 5 ampere, we will receive 0.5 volt. Okay. That means from this negative terminal, that is this point, this is return path, reference path for this IC. So this IC will measure voltage with compare to this point, 0 volt, and this is 0.5 volt. That are voltage drop across the current shunt resistor, current sensor resistor. Now if I will connect multimeter in this point. Let me draw it here. This is circuit output. Then I want to connect multimeter. If I will connect multimeter here, that will wrong. What will happen? Let's suppose this current shunt resistor is 0.1 ohm and I have current sense resistor in this multimeter 0.1 ohm here. Return path, reference point for this IC is the same. We are not changing any reference point, but this feedback network that is going to this IC, that will change. Now we connected multimeter here, that caused to increase the value of this resistor. When value of this resistor will increase, what will happen? Before this we selected 0.1 ohm resistor. Now due to multimeter, the resistor value will 0.2 ohm. If we are considering 5 ampere current, that time 1 volt will come out at 5 ampere, but our control circuit will consider only 0.5 volt because we connected this feedback resistor to provide 12 volt output at pin number 7 of this IC, when it will receive 0.5 volt. So by mistake we connected multimeter here. What will happen now? For 0.5 volt, our current value of this power supply will decrease to 2.5 volt because we connected multimeter here. We will not connect multimeter or any ampere meter or this meter at this point. We will connect in front of this sense resistor. One point is now covered. That is it necessary to use 0.1 ohm? No. We can use any value. You can watch this video number, I will mention here, video number 1336A. That is second part of this power supply. First part of this video is 1336. All videos on my channel are numbered. So this live stream is 1336B. This is first part, second. Now we are working in third part. Okay. Here I discussed how to select the resistor value. If you will use 1 ohm resistor, that time I square R. I calculated the same. If you are using 0.1 ohm resistor, that time the resistor power dissipation will 2.5 watt. If we use 1 ohm resistor, that time we need minimum 25 watt resistor, that will become approximately 4 inches, and that will dissipate power all the time. So now I am using ampere meter. If I use ampere meter, this one, that time I will hook up, as I connected here, I will connect negative lead of the multimeter at this point and positive lead of this ampere meter to the second side of the load. This is load, return path from the load. If I will connect here, it will measure the current. This time it will not take any effect. But when we are connecting this BL-02, here is a special technical point. If I will connect here, black wire here and red wire will be connected at this side, so current will flow in this meter. And there is another technical point. We are powering up this multimeter from the same return path, but this time we need to connect this return path at this point. Why? Because this multimeter, this external ampere meter, will take reference from this voltage value. If I will connect here, negative path here, what will happen? This voltage value plus this voltage value, so this multimeter will read double current. Both points are really very interesting. If we will connect multimeter, this external ampere meter here, current capability of this multimeter will drop, will become half, or maybe it will decrease depending on the resistor value inside this meter. If I will connect here and I will take a reference point or power supply return path at this point, that time this ampere meter will increase more current value because we changed reference point to another point that is offset with this meter, with this resistor. Now, this reference point will be shifted at the output terminal, that is here. This resistor is our output terminal. And we will connect this negative terminal, that is black, for current shunt resistor here. And now our load will be connected at this point. Now it is measuring current. What happened? Yes, now it is measuring voltage and current. 2.1 volt with 1.44 ampere. One point 99 volt. Two volt, 2 ampere, 1.43 ampere. Let me connect this ampere meter as well. I am connecting three current measurement circuits in series. Two point three volt, 2.3 volt, 1.46 ampere. The voltage are good. I need to increase the current. We need to adjust, we need to calibrate the current actually. 1.46. Yes, it's now same. 1.46 ampere, 1.46 ampere here, 2.3 volt here, 2.4 volt, 2.3 volt here. It is not very accurate. Now if I will increase current, 1.5 ampere. Amperes are same, voltage are same. This time the current is not increasing because the voltage are just only adjusted to 2.4 volt. If I will adjust the voltage now, the voltage are increasing. You can see the intensity of the lamp. Current is limited at 2 ampere. If I will increase now current setting, two point 2.13, 5.4 volt, 5.3 volt, 2.44 ampere, 2.48 ampere. So this ampere meter is now working good. Voltage and current. Now the current is 2.5 ampere because voltage are 6.3 ampere. If I will increase voltage, current will increase as well. So in this session, we connected this Deek-Robot BL-02 voltage, ampere and wattmeter. Until now, we are satisfied that its voltage control, current control is working fine. In next session, I will add protections. The first protection, we need over temperature. to the heatsink to protect this transistor. Second, over voltage protection. Let's suppose I need 12 volt or any voltage setting. Let's suppose I will set it to 12 volt. Maximum allowed tolerance must be 10%. That means if this power supply at any case 12 volt plus 10%, 13.2 volt, this power supply will disconnect the output. So next circuit will be protected. We require 12 volt due to any reason, any external interference. If the voltage will increase, it will cut off the circuit. Then next improvement we need output on off. First, second, third. This is third, and fourth crowbar. We need to add crowbar function. If you are working on any 28 volt circuit or 12 volt circuit, we will adjust a crowbar function that this power supply will never exceed than 12 volt, 13 volt. We will set a limit that is called crowbar function. If by mistake I want to set current and by mistake I am setting voltage, or maybe while working, if I will touch the knob, the voltage may exceed, the load will damage. So this crowbar function will protect the next circuit. And finally we will add a AC source. We will connect transformer and any rectifier, capacitors, capacitor bank at input. And if we want to increase current, let's suppose we are making this circuit at 5 ampere. If I want to take out 10 ampere, 15 ampere, 20 ampere, that time we need to consider the input capability. We will take a heavy transformer, or if we want to take 28 volt 10 ampere, we will add parallel transistors here and we will increase the heatsink size, because DC power supplies dissipate power all the time. So if you are enjoying this live stream, don't forget to hit the like button. If you have any question, you can write in the comments. I will try to reply them. Let's see some comments. Yes, Isam, it's necessary 2.1. Okay. Isam, thank you. Sant Sri Devaram ji said hi. Hi, brother. Susanta Atha. Hello, sir. Thank you, brother. Yuvraj Danpal. Hello, sir. Welcome, brother. So until now, we will cover this subject. We connected Deek-Robot BL-02 to this power supply. We injected 28 volt on these two lines. We controlled using coarse and fine voltage adjustment, current control setting. This LM324 is controlling the voltage. It is cool. This gate base driver circuit for this transistor is good. This heatsink is hot. It must be hot because it is working as a variable resistor. When we are using transistor in any power supply, regulated power supply, DC power supply, it works as a variable resistor depending on the load size, depending on our current requirement, voltage requirement. This transistor changes its resistance. In last video there was a comment that can we use MOSFET? No. For regulated power supplies, the transistor is compulsory. We cannot use IGBT. IGBT MOSFETs are used in switching power supplies because its RDS on is very low, that are not working in linear conduction. Transistor BJT works in linear conduction. So we are forced to use NPN transistor, PNP transistors, any BJT to control voltage for any regulated power supplies. .5. So this meter is now measuring excellent. 2.5, 1.5 ampere current here, 1.5 ampere current here. The load is drawing 3.77 watt. So this meter will multiply automatically, that is in its software. It is not very accurate, but it works fine. So thanks for watching, thanks for joining. I will make next session for this video to create these protections, and then we will assemble this circuit on a PCB or on a Vero board, and we will place it in a box to make it a power supply, to make it some good looking power supply. This time I am making on cardboard. It's looking like a fun, but it is not a fun. It is giving us a very clear concept about the circuit flow. So that is reason I draw diagrams on a paper. I can draw in any circuit drawing software. That will not give a clear concept about the circuit. When we see this line is reaching to emitter and we are connecting physically a wire, we can follow the circuit. Otherwise, if I will draw the same diagram in any circuit drawing software and I make any PCB by etching, that will not give a clear concept about the circuit. When we understand the function of circuit, we can follow electronics very nicely, and it is a fun. We can enjoy the work. When we enjoy our work, that is perfect work. Thanks for joining. Bye bye. Assalamu alaikum. Allah Hafiz. Live, where to disconnect live. First time I am making live stream from my mobile and I don't know how to disconnect it. Are you sure you want to stop? Oh, wonderful. I will stop now. Okay, thanks for joining.